Hello, everyone. My name is Curtis White from Beyond Backtesting. That is B Backtesting Twitter, and I think I'm gonna have something that's going to be very entertaining and exciting for you guys. I'm gonna be demonstrating more of my GPT Anywhere code, and I'm working on a premium professional version of it, which we'll have make available for a small fee. But I'm going to be showing the code that I have already freely shared, and be sharing more of that. But I want to introduce, and one of the things I'm going to be doing that's a little bit unique is it's not going to be live coding because I feel like that's too long and it's not enough value. But when I put when I was thinking about putting the video together and I went back and changed some stuff, and I was like, this would be very useful if they could actually see what I was doing. So I've kind of going to go through what I actually did and just kind of do it step by step. So it's like a semi-live session, but more condensed for your value. Now, I have my Twitter up here, and my apologies for probably pronouncing the name wrong, but Giorgio Rubino is one of my, follows me, and I started following him as well. He's a conversational AI technical leader at Alma Wave, and in the past he's been a researcher at ITD CNR, and he's built some CPIA bot. And so he has a led with kind of a question prompt solution here. I'm going to just go through it here. So the question was how to integrate a large language model with a custom API Python function. I did some experiments creating programmatic prompts to instruct Text DaVinci to call specific functions back commands, and he's got a thread here, and he kind of shows the code. Let me zoom in on his prompt. It's a little hard to see here, but he's in the playground, and let me just zoom in here 1 second. Yeah, it's a little hard to see. I have to do something different to show it better, but it starts off, he says, the prompt, it says, "You are Sunny, my weather forecast personal assistant." And the key is when it doesn't know, it calls this weather, it says call weather, and it calls this weather function, and then it somehow returns it to the data. I'm not sure exactly how that gets into the data, if that's automated somehow, or if it's like a monitoring, or if he's just doing it manually. But this is kind of what he's looking at here, and the goal is how do you feed the model with information, right, that it doesn't know. And let's go on. He says, the idea is to have a controller Python program that intercepts the function call and runs it and returns the text data is added to the data section. Okay, the controller inserts. So he's got some kind of monitoring controller. It says it seems to work, but there are two big cons. The program written in the prompt is pretty unstable, sensitive to the natural language instructions, just minor changes in lexicon, limit the generation of the correct back command. All the procedure consumes twice the prompt token count because you need to ask a completion, and it has to generate the back command. He wants to know if this is the right way to do it. Is there an alternative approach? And we're going to look at that. And so I replied, I said, interesting. If I understand, here are 3 alternative prompt engineering solutions. I said, number 1, you can fill in the needed data on the request. If you know the data and it's limited, you could try to fill it on the request, and that would work very well for multi-prompt scenarios. The problem is you have to be able to predict what data it needs, which that could be very difficult. And 2, I said have the LLM return code and use the code to get the data. It sounds like what he's doing, but there's another way of thinking about it, and it may not have many applications for the usage that he's thinking about. But that's kind of what I want to demonstrate, a different way of thinking about interacting with these LLMs in a chat response, but in a little different way. And I'm going to be kind of demonstrating that. Have the LLM return declarative markdown code that is post-processed. So a very similar idea to what he's doing, but instead of calling functions, you would give it tags that would populate, and you would fill those tags in. So the benefit of 1 is that you have the most contained. It's the most contained. There's no code running. It's the most secure, the least likely to leak data, right? And I mentioned, I started talking about simulation good time back, but more recently I started tweeting about prompts as code, and it seems to be that it's kind of there seems to be like a zeitgeist, or I don't know if it's because my tweets has influenced other researchers, but I'm seeing a lot more of that. For example, I've seen Riley Goodside just recently tweeting about the risk of that, and so maybe it's just everybody's thinking of things as kind of like in real time, and it's kind of coming together that way. Or maybe my tweets did influence some people to start thinking that way. I don't know, but that's the downside to the method too. And probably the the method that I think, if I were thinking about doing this in a production setting, maybe the method I would think about is allowing it to return declarative markdown that you then post process and fill in. And the benefit to that is there's no there's the only code that can run is the code that you use for post processing, right? So it should be more secure than the method number 2. And you can also expand it with different tags. The one of the difficulties with the declarative markdown approach is, let's say, and this is when I show my example, I'd actually change a little bit. Let's say you have a tag called temperature, right? And the trick with that is you actually would need to know the location to get the temperature to make it locale specific. So your tags may have to be a little bit dynamic to do that, and they could be something like BB tags, markdown tags. Would be something of that nature. Would be the way I would think about doing that. There may be other ways, certainly not an expert. This is all new, but just thinking off when I first thought about it, I said, okay, that would be some ways of doing it. But what I want to show is this idea of, expanding on this idea of language models returning code versus prompts, and how that can greatly expand the power and capability of what these models can do. Okay, so we're going to be showing the weather example, and but I want to start with just the basics of this idea of LLMs returning code versus prompts. So here versus just plain text. So here I say I've started with my prompt, and I say you are an artificial intelligence assistant. You cannot do math, but you can write Python to do math. Output all your response as Python. Do all calculations using Python code. So I'm going to start with showing just the interaction component. So I'm going to say human, and this is going to be this will lead it into responding as an assistant as well. I'm going to say how are you, and what we want to see here. So I'm going to select all of this because it's going to need the entire prompt, and I'm going to do the Control Enter, which will actually again, this is a certain type of an interface to the model. The number 3 solution is probably what you want for some kind of deployment, but I want to show the power of this for anyone who's actually actively trying to interact with these models. This is an extremely powerful thing I've created here. So I'm using my GPT Anywhere. I'm just going to press Control Enter, and that's going to submit all that as my prompt, okay? And this is what we wanted to see. We wanted to see that it did not respond with just a text, that it generated code. And I can run that code, but it's already run it actually, and you see it here. I'm doing great, thanks for asking. And then also it did a little more than what we wanted here. It went ahead and showed that it can actually do the math. It can do what is 2 plus 2, and it went ahead and showed that it can do that. So what I'm going to do is, we've seen it can do the math here, but can we do something to where it has to kind of maybe utilize the math, right? Let's see this, and again, I'm starting to experiment here, which is obviously liable to lead into unknown territory, right? I'm going to say multiply 500 times 210. We'll do 2. Let's see what I got here. I got 231. And multiply. Let's just try this. Let A equal and B equal times 331, which is larger. Now this is something that requires this requires a little more complicated code, and we'll see if it actually knows. I didn't give it a hint to say do comparisons as well. We'll see what this does. Pretty good. Okay, so it says I'm doing great. Thank you for asking. A is larger, and here's the key: is that we wanted it to use the code to generate this comparison statement, which it did. Now, what I could do as well is I'm going to try a little something here. I'm going to say AI on that, and I'm going to do it because I want it to. We'll see if it responds with the tag. Obviously, that's not required, but it'd be kind of cool if it did respond with the AI tag in front of it on the output. So I did the Control Enter there, selected everything, and we got a problem. It tried to go to the weather API, and it caught it with it's doing too much. So let's just run this. I'm doing great. Thank you for asking. A is larger than B. That's very good. So it did use the comparison here to do that. So I'm assuming that worked. Obviously not checking everything here I'm outputting, but that's what we wanted to see. And we can also do stuff like this, okay? Multiply 500 times 600 and output with comma thousands separator. And I'm not going to select that weather because it's not required yet. I'm going to show you this as well, okay? Great. And so again, we're getting the code generated, which is what we want because that's going to allow it to be accurate. So this is a new way of thinking about interacting with these interactive AIs if you're doing stuff that's actually needs accurate math or things of this nature. Another thing we can do, and we're not writing code here, and it's kind of we are writing code, but we're also interfacing to the AI with a indirect approach so that it can do things it couldn't normally do. So we're writing code, but the code is not necessarily our desired output in this case. It's the answer. We can do some other interesting things as well. So we'll just keep going with this. I'll just type in human, right? And I'm going to do, say cool. Obviously, the one thing we don't have, and this is something I can also implement with my GPT Anywhere, is I can easily make this an expansion string, so I wouldn't have to tap so much. But that can become in the future. But tell me the top three. Tell me top 3 ranked sci-fi movies. Okay. And that's pretty good at outputting it as code. But what I want to do is say output all movies as a data structure that contains a one-line description. Control Enter. And hopefully we'll get our data description here. Let me try that once more. Okay, I'm back, and this time it did it. So we have this area here with the title, year, description. And so we can start to see how we can richly interact with this, and here it prints the movies, get more rich interaction with this. So pretty cool stuff, right? So what I'm going to do now is we're going to go back to the weather example, and I'm going to show you how we approach that problem. And from this, one of the things of doing it as a data structure is we can start to think about sorting or extracting different types of data from that for computation or for interactive manipulation purposes. So let's go back to our prompt, and we start with your AI assistant. You can do math, but you can you cannot do math, but you can write Python code. I don't know if I have to do this as each one. Maybe that I'm having some word wrap here, so that's probably why I don't have to. Let's make that a little bit longer so I can see if that's required or not. So yeah, I can do all calculations using Python code. Let's see if that's an error. If I don't think I can do multi-line comments, but maybe it's still long enough to where, yeah, it's not required. Okay, I guess it'll show me with the syntax highlighting. It's kind of still like to be standardized, but it's because I have such a small screen here for showing demonstration purposes. So what we're going to change this prompt, and we're going to formulate it for the weather. Now, I originally did some weather APIs, but they return a lot of data, I found, and so I've kind of simplified it. And initially, I simplified it to where I had it to output actually just like I said, basically, you can also output variables. And then I gave it just some variables it could output, and that worked. But then I realized that was really not going to be show the example. So what I've done here is I've added these this new prompt, expanded the prompt to say you do not know the weather, but you can access any variables defined to access the weather information. Right, that was the variable portion, and we I didn't have to change that; it worked. But then I had the description here of how to get the weather with the weather prompt, and so we're going to go to the weather Python file I created here. And I started with this idea. Okay, I'm not going to write the function these fictitious functions, and I realized I don't have to do that. So all I did was, I say again using my GPT Anywhere, I just have to give it the description of the function, and then I enter control enter. Okay, I may have to, and I get back this code here, and then all I have to do is give it the description here. And obviously, for an actual use case, we would actually call an API, an actual weather API. I'm going to give you, for those who want to take this to that next level, I'm going to share with you the API I think that could be that I've will make that most attainable that I found. Description. I don't know why that done that. Okay, so here we have, let's run this, make sure this works. Okay, and now we need to get the temperature, and I'm just going to say this is a what's interesting is that it knows, because I'm using this form that's actually incorrect with the int and the types. It knows that Python doesn't have types, which is pretty cool, because I'm more used to C#. So I'm going to say get the temperature, and I'm going to see if it knows. It did properly there, but it shouldn't actually have the type on this. I'm going to get the temp because it's dynamically typed, and I could just do var temp to be interesting too. Well, we'll just stay with int. We'll do var. Okay, and we'll see how this works. I'm going to give it all of this. Let's see here. I didn't complete this here. Okay, get weather description, city, state. Oh, that should be get. We'll make this get weather temp. That's what we want to make this. Okay, we're going to go back to here, and I'm going to select everything, control enter, and we should get a function to get the temperature. Okay, really good, nice. Okay, now what's nice is I can just say show example show example for both functions above. I did a control enter there, and now we've got the we've got a problem here. Let's see what we've done. Line 15. Okay, I don't actually see the problem. It says string is not callable. Let's see here. I don't know why that. I'm not sure. Let me. So here'd be an interesting thing we could try as well. As I can say, I'm just going to say it's a type error. So apparently something is. So type mismatch. There's some kind of type thing it doesn't like here. We'll just see. This is at line 15. It says line 5. That's the function for that. Is I see here. Return description. Instead of returning, this is the problem. It just needs to return the description. That's the problem. Okay, we don't have to fix it. So a little bit of a problem there. It called a function instead of returning it. Let's see if this works now. Okay, so that did work. And now what we want to do is all I need to do is to copy the examples. Okay. I don't need the output, and actually I don't need the examples to be called in this file either, but what I want to do now is I'm going to copy these. I don't need the print even. What I do need is I do need something like this. description equals and temperature equals, okay, and I can copy these descriptions into the prompt, and it should be similar to what we got there. I think it's exactly the same, except I used the var, which is incorrect, so we'll leave it as it was, but that's essentially all we do. Now that we have this new code, and now we can ask it, we can see if we can get some weather back. Okay, I'm back, and so what I've done is, as you can see, I've made a small change in that I'm not giving it the abbreviation, and the goal is if we can do with a small slight change here. And I'm going to do Control Enter, and the goal is that it will call the function, the method correctly. So that looks pretty good. Let's see what. Okay, the weather in New York is New York is cool, windy, and partly cloudy. Scattered showers with a temperature of 73 degrees Fahrenheit. So that looks pretty good. And so what we're seeing here is it is using the weather function. It actually did some pretty cool stuff here with this. Which is okay in this case because we're running in real time, you know. And if you were doing it in another format, this would non-dynamic may not be desired, but this is really what we wanted to see. So we'll see if we can do something a little bit more of a change, okay. And let's just see. Let's say Colorado, and I'm going to try. I'm going to try without even giving it the state and see if it can give it the state. So this is a little more of a change. Okay, but pretty good. Again, it was able to use the proper form there, the abbreviation, and the city. Okay, nice. Okay. And we got a nice little description back there, weather in Boulder, Colorado. Okay, obviously it's always going to return the same thing, but we're trying to see if we can deal with these differences in context, because that was one of the original problems that that was shared in the method he was sharing. And so now I'm going to give it something a little more challenging. I'm going to say San Francisco, but I'm not giving it even the state. Let's see if it can generate the state. Okay, that was not what we wanted to see. Let's make sure I got everything selected. That's not what we wanted to see. Okay, Control Enter. Okay, good deal. Okay, so now we have it was able to infer the state properly and generate this completion here. Okay. So that's pretty good. Okay, so this is again showing how we can interface to these methods and utilize this in a simulation environment. And initially I thought that was the demo because I looked at some of these weather APIs, and they were pretty advanced, and I was like, I'm not going to have to parse all this JSON and connect to these APIs for just a demo. Be writing a little bit of code at least. And but as I worked, I really seen the efficiency of working with my GPT Anywhere. And so if I could find just an API that's a little bit simpler, I could probably do that very efficiently. And actually, I was able to use my GPT Anywhere code and just write comments, and was able to connect to an actual weather API. And now this is actually fully functioning code. I'm going to show how I did that, but I'm going to recap what we've kind of went over here. So we went over how we can interface to GPT models and have them return code, which gives us a lot more capability for doing factual type stuff instead of returning just simply prompts. So we're in a prompt code type of a real-time environment. That's what we've shown here. But the other, so that's one side, and in that respect, the code itself may not be of interest. We can use the code to generate answers. But in this next part of this, we're actually going to we also showed a little bit of generating code, how you could generate code for code generation purposes for that you may want to reuse later. And what we're going to do now is I'm going to show you some real world code generation for accessing these APIs and things. And actually, I didn't write any real code for this, any code at all. I just wrote descriptions. I just wrote the comments, which is pretty impressive, right? So let me first demonstrate that this works. So I did change a few things here. I said always use this because occasionally it would return back with just text. Most of the time it was working without that statement. You can always you can use some of my examples show how you can use assert and just run the code just now or something. You can show how it can show how you can use assert to get better response, or put rules at the end of your prompt, and that's some prompt engineering stuff. So this was a very quick prompt. It didn't do much very much testing on this prompt. You could always do that and to get a better response. But let me just show you how this works. So, I think it pulled back my previous one. So we're seeing 69.1 degrees, but this is not from generating because there's no code here. So I'm going to control enter this, okay? And we should get the code generation here. And there's our code generation with our prompt in 69.8. Changed a little bit. We can see that it's working. What we'll do is I'll go up to Ontario, Canada, and so we can see that that it's working, or at least it appears to be working. Okay, and we got for Florida it's clear. Okay, for Ontario, Canada. See what we get here. Okay, it's generating the code. That's what we want to see that. And we got an error. We got 14 degrees. Name D is not defined. Oh, that's something it just, I don't know why it did that. Okay, so we got 14 degrees, partly cloudy. We see the temperature has dropped off. And I did put this little underscore F. Always, we can give it the algo a hint. We can get, it can usually infer just from the smallest hint what we're meaning. And now just for the last test, I'll just say San Francisco, California. Not to be confused with San Francisco, Costa Rica. And we've got overcast with 46 degrees. So we can see this is working. Let's just see if it can do San Francisco, Costa Rica. I don't know if it has that. I don't know what the abbreviation is for that. So this is kind of, again, now we're going outside the bounds of what I've know would know to work, and this may work. Okay. And we've got 71.6 degrees, so we can see it's partly cloudy. We can see it's working. So this video is already pretty long. So in part 2, we will go over the actual code generation.